See, we start from here. Okay, this is a circular measure. So circular measure is about circle. Okay, so first of all, we need to understand radian. So actually, what is radian? Radian is a way to measure angle. So you know we can measure angle in degree. So now we can measure angle in radian. Is another way. It's something like length. You can measure it in meter. You can measure it in inch. So it's that kind of idea. Okay, now here the first point, you can see the angle theta in radian subtended by an arc of length SCM of a sector with radius RCM is defined as, okay, that means this is the arc, this is the radius, the angle is here, but the angle is in radian. And you want to know about radian, you have to use this formula. Theta equal to S over R. Theta equal to S over R is a formula that relates between the arc length, the radius, and the angle in radian. So let's say for example, if I have a sector like this is called a sector. Okay, this is 4 cm, and let's say this is 5 cm, and let's say this is theta. Okay, if I want to find theta, I can just use this formula. Theta equal to S over R, or at most of the time we call it S equal to R theta. So it just rearrange the formula. Okay, so we know that this is S is 5 cm, R is 4 cm, the radius. So if I use S equal to R theta, or theta equal to S over R, both will be just fine. So S is 5, radius is 4, and then we get 1.25 radian. So that is the angle in radian, 1.25 radian. Okay, so how big is radian? Let's take a look at the information here. The angle subtended by an arc with the same length as the radius of the sector is 1 radian. So what they're trying to say is, if the arc and the radius are same length, then it is 1 radian. Okay, so let's say for example again, if this is 5 cm, this is 5 cm, this is theta, so theta equal to S over R, so S is 5, R is 5, so end up with 1 radian. Okay, so that is the idea of 1 radian, and they give information here. 1 radian is actually, you want to know how big is it in degree, then you just take 180 degree divide by pi, then you will get the angle in degree and minutes, 57 degree and 18 minutes. Okay, so the other important angle is pi radian. 1 radian is not important one actually, so pi radian is important. Pi radian is 180 degree. This is very important. Okay, so how important is it? Let's say I give you more example. When you know pi is 180 degree, okay, now let's say I ask you, pi over 2 is how many degree?
360.
360. It's not actually. You divide by 2 here, and then you have to divide by 2 here as well.
90.
90 degree, yes, correct. 90 degree. So 360 degree will be 2 pi. 2 pi. So imagine that pi is 180 degree. So you times 2 on the left, then you times 2 on the right. So you will get 360 degree. Okay, now let's say I ask you another example. Pi over 3 radian is equal to how many degree? 60 degree. Yeah, correct. 60 degree. Yeah. So I guess you roughly know how it works already. Pi over 4. Yeah. Okay. Pi over 4 radian is how many degree?
Pi over 4 is 45 degrees.
Yes, correct. 45 degree. And pi over 6 radian?
30 degrees.
30 degree. Yes, correct. Okay. Now let's talk about the formula to convert. Okay, it's not given here. You see our first exercise. Convert each of the following angle to degree. Angle to degree. They give us angle in radians. So you have to convert it to degree. That is actually a formula. The formula is going to be like this. If you have degree, you want to change it to radian, then you times pi over 180. If you want to change from radian to degree, then you times 180 over pi. So for example, you can see here, they give us angle in radian. So they change it to improper fractions, 1 and 1 over 3, right? They change to 4 over 3 pi. Then you multiply with 180 over pi, as you can see here, 180 over pi. Then you will get angle in degree. So of course the calculation will be like this. You cut the pi away, then you just press calculator, like 4 times 180 over 3, then you get 240 degree. Okay, so let's say I move on. Okay, all this I leave it to you. Now let's see B. Convert each of the following angle to degree and minutes. Use pi equal to 3.142. Okay, so you can see, okay, again, let's look at the formula over there, which is this formula. So you have radian given, you want to change it to degree. Radian to degree, you do 180 over pi. Okay, so we do 2.7 times 180 over pi. But the question said, use pi equal to 3.142. So pi is 3.142. Then you press calculator. Okay, so let's say you press it now, and you let me know what you get when you press all this. Okay, so you take a try now. 2.7 times 180 divided by 3.142. So what you can see from your calculator. Yeah.
154.68.
Yeah. Okay. You will get 154.68 degree. So if you want to change it to degree minute, so there is a particular button in the calculator, which is like this, followed by comma, comma, comma. So you can press that. Then you will get 154 degree, and then 42.78. You will see something like this. This is actually minutes, and this is seconds. 1 minute have 30 seconds. Okay, 1 minute have 30 seconds. I'm sorry, 1 minute have 60 seconds. So whenever this is more than half means more than 30 seconds. Okay, so more than or equal to 30, then you have to plus 1. Okay, so that's why this is 42, more than or equal to 30, so we plus 1 to this, so that's why we get 41 here. 154 degree, 41 minutes. Have you used this button before?
No.
No, okay, so that means you can either put your answer in this way. If the question never said degree and minutes, you can put in this form. But if they put the question in this way, then you have to press this button and change it to degree minutes. So it depends on questions. Okay, now let's yeah.
If like let's say the 42 is exceeding 60, then need to plus 2.
You mean this value? Or this value they won't give more than 60. Yeah, maximum 59 only, 59. Okay, so they won't give more than 60. Okay, so that's the thing. Now let's see the next one. Part C. Convert each of the following angles to radians in terms of pi. In terms of pi. So now they give us degree. You have to change it to radian in terms of pi. So let's come back to the formula again. So this is the formula. Degree, you multiply with pi over 180, then you get radian. That's the formula. So you take this degree, multiply with pi over 180. So they say in terms of pi, right? So you don't change this to 3.142, So you have to remain the pi over here. So what to do is you just take 132 divide by 180 by using calculator. Then you will get 11 over 15 and the pi you remain there. Okay, so that's how it works, and that is how the formula works over here. Okay, so the formula is, this formula is enough for us to change from degree to radian and radian to degree. Okay, now let's move on. We look at the next page. Okay, so this page finished. Next page. Okay, this is the next situation. Convert each of the following angles to radians, correct, to 4 significant figures. So this time they don't want answer in terms of pi. They want you to put it in 4 significant figures in decimals. Okay, again, this is degree. You change to radian. So remember that degree to radian, we multiply with pi over 180. So of course if you do backward, it's 180 over pi. So because of that, we take the degree, multiply with pi over 180 degree. And since they said 4 significant figures, so you can just change this. You can just press calculator together with pi. So which means when you press calculator, you just press like this, 72 degree. The degree is this button. Then 34 minutes. The minute is again the same button. Okay, the same button. And then after that, you times pi. When you times pi, right? So my suggestions, you use the pi in the calculator. I don't know what calculator you are using. Basically you have to find out the pi somewhere at the bottom. For my calculator is this button.
The minute how to press?
We press this button. The same button.
But the degree,
they put a circle here, right? Sorry?
The degree came out instead. There's no minute.
Oh, yeah. The calculator screen will show a circle here, but it is actually a minute. Yeah, it's actually a minute. So your calculator will show something like this. 72 degrees, 34, circle like that. In fact, this is minutes. Yeah, this is minutes.
Okay.
Yeah. Then you times pi. Are you able to find out pi from your calculator?
Yes.
Okay. Then divide by 180. Okay. times pi divided by 180. 180, should you put degree or not? Not compulsory. Okay, so after that you press equal, then you may get something else. In order to get 1.267, you have to press this button again. Okay, so are you able to get 1.267?
Yes.
Okay, so consider center for this. Now we look at the next subtopic here. Okay, so if you are wondering why we want to change degree to radian, so actually the main reason is because we want to use this formula, S equal to r theta. This is a formula to find arc length easily. To find arc length, which is this one, the arc length. You want to find arc length, you use S equal to r theta. Theta is given in radians. Okay, so S equal to r theta. So of course, if let's say you are using your theta in degree, then you can't use this formula anymore. You have to use basically what happened here is you have to change it to radians. Okay, you have to change it to radian. Now you know degree, you see here, degree change to radian, you need to times pi over 180. Okay, so that's why if you see this, they take the angle in degree, multiply with pi, divide by 180. This is to change it to radian, you know, to change it to radian. Okay, it's based on that formula, the formula that we discussed just now. They change it to radian, and then after that multiply with r. So you have two options here. So if they give you degree, you use this. If they give you radian, then you use this. Okay, now let's see example. Of course, S equal to r theta can be rearranged to other form. You can rearrange to this form to find theta. You can rearrange to this form to find r. Okay, now let's see part A. Calculate the length of arc. Length of arc is basically S. Calculate S of each of the following circles or sectors. Okay, now let's see example. So as you can see here, they give us radius 5.4. They give us theta 1.82. It's already in radian. So we use S equal to r theta. So r is 5.4. Theta is 1.82. So S equal to r theta with times. We are using this formula. Then we get 9.828. This is the arc length. Okay, another example. Now they give us degree. Okay, they give us degree. So you see they are changing the 195 degree to radian. That times pi over 180. They change it to radian. Okay, so once you change it to radian, then you can take this formula, S equal to r theta. So take the r, 7.5, multiply with the theta, 3.404, then you get the arc length. Of course, if you don't want to change it to radian over here, then the alternative way is you use the formula here. S equal to theta over 180 times pi times r, where it is shown here. Take the angle, divide by 180 times pi. Actually, this is the process of changing to radian. And then times radius, and then you get 25.53. Same answer. Okay, so you get the idea or not for these two examples?
Yeah. Yes.
Okay, now let's move on. Okay, now let's see here. So like what I mentioned just now, our formula is S equal to R theta. So you can just rearrange it to R equal to S over theta, or theta equal to S over R, to find out R and theta. So for example, okay, let's say this one. They give us this and this. You want to find S. So we use S equal to R theta. We take this times this, as you can see here. Then you get the arc length. Okay, this example, this time they give us radius and arc length. You are going to find theta. So we use this formula, theta equal to S over R. So that's why you see here, S over R. So S divided by R, then you get angle in radian. Okay, now example again. For this time, they give us theta and S. Theta and S. You want to find R. So you use this formula, R equal to S over theta. S over theta. So you divide, then you get 3.6. Okay, so we are just playing around with the formula and find out whatever necessary. Okay. Now let's move on. Part C. Calculate the perimeter of the following shaded segments. Okay, so what is segments? Let's say we discuss a bit here. Okay, now let's look at the term here. So this is called circle. So this is called a sector. So segment is actually, you have a sector, you add one line from this corner to this corner. This particular part is called segment. Okay, segment. So they want us to find the perimeter of the segment. So to find the perimeter of the segment, basically you need to find this one, which is S equal to R theta, and this one. This is called the chord length. Okay, chord length. So this is called the arc length. So basically, to find the perimeter, we need to use chord length plus arc length. Okay, so of course arc length you already know. We just use S equal to R theta to find the S. But how about chord length? Okay, chord length, so that is a formula. So the formula for chord length is given here. You can see perimeter is length of arc plus length of chord. Length of arc, R theta, we learned this, S equal to R theta. Length of chord is 2R sine theta over 2. 2R sine theta over 2. This is the formula for length of chord. When you use this formula, you must be careful. Okay, so maybe I write at the side here. S, okay, here will be better since I have this here. Okay, so chord length 2R sine theta over 2. Arc length R theta. Okay, so what to be careful about is the theta. The theta here is a little bit different from here. So this theta, right, must be radian. Must be radian. But for this theta, right, okay, for this theta, it depends on your calculator actually. So depends on your calculator. if your calculator is in degree, then of course you can use degree here. Okay, so how we know whether our calculator is in degree or not in degree? So basically you can just check the screen. So this is the calculator, right? If you see a D somewhere here, and then it's degree. Okay, in degree mode. But if you see your calculator having a small r here, then it is in radian mode. So by the way, your calculator is in D or in R?
D.
D, huh? Okay, let's say if it's in D, and then we handle it in this way. Let's say one example. Okay, one example, in D. Let's say we don't want to change. Sometimes changing it give us trouble also. In mathematics, we don't use radian. You change it to radian. After that, when you do mathematics, maybe it affect. Okay, now let's say they give us 40 degree and they give us 5 cm here. They want us to find the perimeter of the segment. Okay, then we use this formula. So perimeter equal to 2r sine theta over 2 plus r theta. Okay, like what I said, this one must be radian. This one depends on your calculator. So your calculator is in D, in degree. So I use degree. So this one must be radian. Okay, then we change it to radian. 40 degree times pi over 180 is equal to 40 over 180, so 2 over 9 pi. You can change it to decimal, or you can remain it in terms of pi. It's up to you. Okay, so now I use a formula 2r sine. Okay, remember your calculator is in D, and then you use degree, 40 degree. If your calculator is in radian, then here you substitute with 2 over 9 pi. Put it up here. Okay, if your calculator is in radian mode. Okay, so it depends on your setting actually. So let's say now your calculator is in degree mode. So you put here degree over 2, and then plus r. R is radius 5 cm, theta 2 over 9 pi. So you can see your calculator is in degree, and then this one you put degree, this one you must put radian. Okay, then after that we just press everything. Okay, so let's say I press it here so that you can see what value do we get here. Okay, so sine. So you will get 6.911. Okay, so this is the parameter, 6.911. Okay, now let's see another example given here. So this is the example given. They give us radius 6.3 cm. They give us angle in radian 1.8. Okay, so you can see what they use here. They are using this formula. After factorizing the r, they are using this r, then 1.8 plus 2 sine 0.9. 0.9 because they divide by 2 already. Okay, so if you are using 1.8 over 2, 1.8 over 2, that means you are using radian here. You are using radian. If you are using radian, you must change your calculator to radian mode. So that's why make sure the calculator is in Radian mode. If you don't want to change to Radian mode, then you change this to degree, and then you can put degree over 2. Okay, so you have two options here. Okay, so this is where they use radian divided by 2. So you have to change your calculator to Radian mode. By the way, do you know how to change it to Radian mode?
No.
Oh, what calculator are you using?
Casio, the class is one of the latest.
Okay.
The FX. Yeah.
FX570EX.
Yes.
Okay, so you have to press shift menu. Okay, right here. Shift menu. Then you can see number 2, angle unit. You press that. Then after that, you change to Radian mode. You press 2. So after doing so, then you will see the screen show R. But remember one thing, when you do mathematics, please change it back to degree mode, because mathematics, they never use Radian mode. So mathematics, you just press shift menu, angle unit, then change it back to degree, choose 1. So now you are in Radian mode. If you are in Radian mode, then this one can use Radian. So that's why they are using Radian here. No, 1.8 divided by 2. Then press and then get this. Okay, so
If it's
yeah,
need to divide by 2.
degree. Yes. No matter degree or radian, you need to divide by 2. Yeah. So let's say if it's degree, let's say you like degree mode very much. You don't want Radian mode. Okay, how we do it? Okay, let's see. We discuss about this. If I like degree mode very much, okay, so in degree mode, okay, I change my calculator back to degree mode first. Okay, now let's discuss on what to do. So first you change 1.8 to degree times 180 over pi. 1.8 times 180 over pi. So I get 103.13 degree. Okay, I have degree here. Now I use this formula. Parameter equal to 2r sine theta over 2r theta. My calculator is in degree mode, so I use degree. But this one must use radian. Okay, then you do like this. Parameter equal to 2r sine theta in degree over 2 plus r, and now the theta must be radian, 1.8. Then at the end, you will still get the same answer, 21.21. So these are the options available. A bit confusing. You need to think slowly sometimes. So if you put in degree mode, then this is degree over 2. If you put in radian mode, then you must use 1.8 over 2. At the end, same answer. No matter which way you are using, same answer. Okay, so be careful with this.